Modeling and solving problems with quadratic functions. For the first example, two numbers have a difference of 18. Does their product have a maximum or minimum value? Determine the value of the two numbers. So let's let one number equal x. And the other equal y. If you have a difference, y minus x equals 18. So the difference between the two of them. We want to put y in terms of x. So if we move x to the other side, y equals x plus 18. So we're going to use this as our one number and this as our second number. Does their product have a minimum or maximum? So we want to know what their product is. So let's say P equals x times x plus 18. And if we look at this, our a is positive in front of our x over here. So we know that it's going to open up. So if it opens up, that means we have a minimum value. That could look like an M. So we know that there's going to be a minimum value. So we want to find our vertex to figure out what the minimum product could be and what the minimum numbers could be. So if we look at this, our x1 would be 0 and our x2 would be negative 18 because it's already factored, it's in factored form. Leave it like that. So if we wanted to find our x value at our vertex, we're just going to go 0 plus negative 18 divided by 2, so x would equal negative 9. So at our vertex, we have a negative 9 for x. Now we want to solve for y. So we're going to put it back into the equation. So really we're looking for y. So this equation helps us solve for y. So we're going to plug it into there. Y equals negative 9 plus 18. Therefore, y equals positive 9. So our vertex is at 9 and 9. And if we want to find our product, we'll use this one. So P is equal to negative 9 times negative 9 plus 18. So negative 9 times 9, as we know. So our product is negative 81. So this is our product, and this are our two numbers, negative 9 and 9. For the next example, two numbers have a sum of 20. Does their sum of squares have a min or a max? Determine the values. So let's let one number equal x, second number equal y. So their sum, x plus y, equals 20. So y will be equal to 20 minus x. So here's one number. Here's the second number. We want to know if the sum of their squares has a minimum or maximum value. So let's say S, their sum, is equal to the sum of their squares. So each of them are squared and we're adding them together. And because this is a binomial, it's the same as multiplying it by itself. So we're going to expand this out. X squared plus 400 minus 20x plus x squared. So we're left with 2x squared minus 40x plus 400. So this time I'm going to put it into standard form. So if we go S equals, divide both of these by 2, 2 x squared minus 40 or 20x. Leave a space, plus 400. Find your C value. 20 divided by 2 squared, which is 100. 10 squared. So we're going to add 100 and subtract 100. So S equals 2 bracket. We're going to factor this, x minus 10 squared, and we're going to bring this out. Plus 2 times negative 100 plus 400. It doesn't look like a 0. So S is equal to 2 bracket x minus 10 squared. 2 times negative 100 is negative 200, plus 400 is plus 200. If we look at our equation, we notice that it's positive, so it opens up. So we have a minimum value, and our vertex is at 10, 200. So we know our x is 10, so we're going to sub it in to figure out what our y is. So y is equal to 20 minus 10, so y is also equal to 10. And because we found our vertex, we know our min value is 200. Every week, a takeout restaurant sells approximately 2,000 chicken wraps for $1.50 each. Through market research, the restaurant manager determines that for every 10-cent increase in price, she will sell 100 fewer wraps. So what we're doing is we're going to find the parabola equation to find this point right here, where the price is maximized and the amount sold is maximized. So the first thing is to make two equations. So the equation for the price would be $1.50 plus 0.10 10-cent increase for every however many increases there are. The number sold, I'm just going to put number, is going to be equal to 2,000 minus 100 for every increase. So those are our two equations. And our revenue, let's call it R, will be the two of them combined, the price times the number sold. So this is our big equation. So we want to simplify this to find our vertex to know the number sold and the price, the revenue made. That was what our x-axis is, and this would be our revenue. First we're going to multiply this out, so R is equal to 3,000 minus 150x plus 200x minus 10x squared. So our final equation is R equals negative 10x squared plus 50x plus 3,000. We're going to put this into to standard form. So we're going to divide this by negative 10. So we have R is equal to negative 10 x squared minus 5x, leave a space, plus 3,000. Find your C value. So we're left with 25 over 4. So we're going to add 25 over 4 and minus 25 over 4. Factor the inside. So R equals negative 10x minus 5 over 2 squared. Bring this out to the outside, plus 3,000. So our final answer, you can put it as a decimal even, R equals negative 10 x minus 2.5 squared plus 3062.5. So the vertex is 2.5 and 3062.5. Now because we're going up in increases of 10 cents, we can't go up an increase of 2.5. So we're going to try it with x equals 2 and also x equals 3. Because it's right in the middle, let's try them both. So to find our revenue, we're going to just sub the 2 into the equation. So R equals, and we can use our first equation first. So R equals 1.5 plus 0.10 times 2 times 2,000 minus 100 times 2. And if you type this into your calculator, you should get 3060, so that's their total amount they can make with 2 price increases. And if they make 3 price increases, it'll be R equals 1.5 plus 0.10 times 3 and 2,000 minus 100 times 3. So R will equal also 3060. So either way, if they increase by 2 or they increase by 3, they'll have a maximum revenue of $3,060. The prices will be $1.50 plus 10 cents times 2, so $1.70, or $1.50 plus 10 cents times 3, or $1.80. So our maximized prices to sell the chicken wraps are $1.80 or $1.70, and both will have a maximum revenue of this. So it doesn't matter which one you do. So a student parking pass costs $20. At this price, 150 students will purchase the pass. For every $5 increase in price, 20 fewer students will purchase the pass. So first make an equation for the cost. So cost will be $20 plus $5 times your increase. Your amount sold, let's go S is equal to 150 minus 20 times however many are sold. And your revenue will be equal to the product of the two. So 20 plus 5x and 150 minus 20x. So same kind of parabola, the number sold and the revenue. So we're going to simplify this. So R equals 3,000 minus 400x plus 750x minus 100x squared. So we're left with minus 100x squared plus 350x plus 3,000. So we're going to complete the square to find our vertex, put it in standard form. So divide these both by negative 100. So it's going to equal negative 100 x squared. You simplify this fraction, it should be 7 over 2x. Leave a space, plus 3,000. Find your c value. So 7 over 2 is the same as 7 over 4, which is 49 over 16. So we're going to add 49 over 16 and subtract 49 over 16. This is going to factor, so we're left with R equals negative 100 x minus 7 over 4 squared. This is going to come out, so we have minus 100 times negative 49 over 16 plus 3,000. And if you simplify that with decimals, R will equal negative 100 x minus 1.75 squared plus 3,306.25. So if our x equals 1.75 at the vertex, we're going to round this up to 2 because we're not going to have a 1.75 increase. We're going to substitute the 2 in for our cost to see how much you're paying for it. So C will equal 20 plus 5 times 2. 5 times 2 is 10, plus 20 is 30. So the maximum cost you can sell is for $30, and the revenue you will make will be 20 plus 5 times 2 times 150 minus 20 times 5, and you should get, when you type this all out, $3,300. So the maximum cost to sell is 30, and the maximum revenue you can make is $3,300.